So let's go back to this problem which we had seen to try and identify whether two students in this class are born on the same day and same month.
Okay.
Right. So we have seen, of course, one way to do it, which is to
sort it.
Yeah. Before that, we did this nested loop.
Huh.
And then we made this nested loop efficient by doing some binning and looking only within a month.
Binning, yeah, we did an interesting thing. We binned by month.
Yeah. So we said, okay, we don't need to compare everything across all the cards, but within March, within April, and so on.
Correct.
And then we said that if we instead arranged it in order of birthday by
both of them are costly. I mean, the business of comparing every card is costly, but binning reduces it somehow.
Yeah. And
sorting is itself costly.
Yeah. So once you sort it, then the two birthdays that are identical will come next to each other.
So sorting, without sorting can you do? I mean, if you have a large number of cards, you should not.
Yeah.
Sorting can take.
Yeah. So now we have been doing this new thing of indexing by some name.
Dictionary.
Right? So we have this dictionary. So supposing we maintain a dictionary in which the index value is the birthday.
Full day. Full birthday.
Full birthday. That
not
is
June.
whatever
not
we have.
Month.
Yeah, month and date in that.
3rd June.
3rd
June becomes the dictionary.
And we count.
Count how many people have 3rd
Yeah,
June.
so we keep a count of how many people are born on each day.
Just like we did shopping will category.
Like we were counting how many food items each person had.
So this is cool, no? So then basically because the dictionary is efficient. Why we know dictionary is efficient? Because computer tells you how to go to
you can quickly update something or look it up or see if it's not there.
See if it's there or not.
Yeah. So you can do that, right?
So that must be, then that's really fast.
Yeah.
It's really fast. Then you don't have to compare every card with every card. So
yeah. So we'll just in one scan we can build. We can build this dictionary in one scan, and then check whether there's any item which appears
which has a count of
at least 2, right? That means there are at least 2 people born on the same day.
Let's keep the card IDs.
Yeah, let's keep the card IDs.
Right, because then we'll know.
So we'll know who it is also. Yes.
All right. So what are we doing? We are maintaining a dictionary.
Yes.
Where the first column is the what is it? It's the date of birth.
Yeah, it's the day and month.
Day and month. So 3rd June we'll keep.
Yeah.
And the second is the card ID.
Yeah.
Right?
Yes.
And then what we want to do at the end of this procedure of iteration is we want to see whether or not this dictionary contains any element.
Yes.
Which has 2 entries.
Yes.
Right?
Correct.
There's 2 cards in it. Okay. All right, let's go.
Yeah.
So the first is 3rd June.
Okay. So just to simulate that we are going to find it fast, I'm going to, because we know that these are birthdays, days of the month, that June is roughly midway.
So you're going to write in the middle.
So I'll write it, so this is January to June, and this is going to be July to December. So I'll write it somewhere here. So I'll write somewhere here that 3rd June, and the number is 1.
1. Card number is 1. Okay. Then 5th May.
5th May.
3.
Card number is 3.
4th Jan. So right on top, I guess. 4th Jan. Card number is 2.
Yeah. So this is not the count, but the card
number. Yeah. And if there is more than one card, we'll put a comma and like a list.
We are collecting a list of cards.
List of cards. 22nd September.
So it's somewhere here.
15. 17 July.
Okay.
22.
Okay.
23rd July.
Okay.
14. 28th February. 8.
Okay.
14th Jan. 12.
Okay.
17th November.
Okay.
4.
Okay.
7th November.
Okay.
0.
Okay.
So because of your technique here, you know whether it's there already or not.
Yeah.
Quickly. That's probably the computer is doing something.
Computer
like
is doing something like that, right?
17th September.
Okay.
20.
Okay.
15th March.
Okay.
21. 22nd July.
Okay.
26. 12th Jan. 10. 26th December. 24.
Okay.
6th May.
Okay.
13.
Okay.
16th May.
Okay.
25. So far we have not seen anything, right?
No.
Common. 4th March.
Okay.
27.
Okay.
30th August.
Okay, so I'll write it below September because I run out of space.
19.
Okay,
13th October,
okay,
29.
okay,
14th December,
okay,
17. 23rd March,
okay,
6. 10th September,
okay,
28. 30th December,
okay,
16. 6th December,
hmm,
9. 13th May,
okay,
23. 15th March.
aha, we have a
7.
15th March already.
Oh, you have? Oh,
Yes.
wonderful. So we found the second. Yeah.
7.
7.
Mhm.
8th Feb,
Okay,
5. 9th October,
okay,
18.
okay,
30th April, 11. So this not only told us that we have one item with two,
Yeah.
a list with two elements,
Hmm.
but it also told us that for all others there aren't any.
yes,
So there is only one
correct. There's only one birthday which is in
birthday
common.
common.
Yeah,
And
And-
we did this very efficiently because we use the dictionary.
Correct.
Straight away go there
yeah, an update.
and update.
So we kept a count implicitly. We kept a count for every day in the year,
Hmm.
but we only actually used the count or the list for those days which appeared. So this is another thing. By looking at which all names appear in this dictionary, we actually know which days are actually birthdays of somebody in the class.
Oh, okay, that's another thing we can get. It's a
Yeah.
side effect, right?
So we can actually get from these.
You can get all the birthdays.
Yeah, from the indices, we know which
How
values
many
are
are there? Can you count how many birthdays are there? Just
Well,
curiosity.
it should be 29.
It should be
because
29.
1,
Correct,
2,
correct. You're
3,
right, yeah.
5,
So 30 minus 1, right? Because 1 is
Yeah,
common.
13.
29.
16, 20, 22, yeah, 29.
So we have 29 birthdays and 30 students,
Yes.
right?
Yeah. But this idea that you can actually keep track of the values also by how many values have come
Huh.
is also interesting. So it is an interesting extra benefit that you get from a dictionary, that to know whether something is so. If you ask the following question, when I get a new birthday, does somebody have this birthday already or
have it,
not?
yeah.
So that is part of the process of looking up the dictionary.
Correct.
So we can also use it to keep track of how many different
Birthdays
birthdays actually have come. And so in the previous thing, for instance, when we were looking at shops and customers, if you are doing it, you can also see who are all the customers whose bills have come. So whenever you use names as indices, then
So we have seen some very interesting things, right? So we have started with lists, simple lists. Then we sorted the lists, ordered the lists. Some use of it. Now we have some very interesting. This is not sorted actually.
yes.
This, though you have written it like this.
Yeah, even here
No,
it's not
sorted.
sorted because I wrote August after
So
September.
it's something, it's some jumble of things. But
Yeah.
you have a way of randomly, directly going
Yes.
to the
Yeah.
dictionary element and doing some update on it. And then what we saw basically is that inside the dictionary element itself, you can have a list.
Yes. Like
Right.
here, these are lists.
That's a list.
Yes.
So we now have a combination of a dictionary and a list.
Yes.
That should be quite a powerful.
Yes.
Organization,
So
right?
basically, in a variable, you could have a dictionary or a list,
Hmm.
but what is there inside a list is also or a dictionary is also like a variable, so it could also be a list, and so on. So you could
have a very powerful. It's a very powerful way of organizing now,
yes.
right?
So we have very complex ways now of arranging our
Arranging things.
And
Hopefully we can use it, right? We can use
Yes.
it to solve some
Yes.
different types of problems.
Yeah.